Today we're going to start talking about half-life. Half-life is the time required for, just like the name sounds like, 1/2 of a radioisotope's nuclei. Just like the name sounds, half-life is the time needed for 1/2 of a radioisotope's nuclei to decay into its products. So you'll see the shape of the graph right now, and you'll see originally all of them are the original type. At the time 1/2 right here, half of them are blue and half are yellow. After another half-life, we'll see it transform again to now 25%, and then here 12.5%. So it'll keep going and going. Technically it never gets all the way to 0, but we'll just see it getting smaller and smaller until the amount's insignificant. On this page, I would like you to color it so it matches this. You can use one color for the radioactive. You can borrow one of my highlighters. So originally, all of the substance here is radioactive. So go ahead and color all of those in. On the second part, we're only going to keep half of them being radioactive. So half of them have transformed. And then I want you to make it so that only 1/4 are, and then finally 1/8. So the way this equation would look, this is the equation for alpha decay. So originally we would have 216/84 PO. It would release an alpha particle, and it would become 212/82 PV. So the red represent the original radioactive substance, so right here, the parent nuclei, and the blue represent the daughter nuclei, what it's being transformed into. So what we're going to see on here is there is some methods of doing these problems, and there's two main types on here. So the first type on here would be given 2 times and one amount, and you'll be asked to either find the starting or the ending amount. The other types are you're given 2 amounts and only 1 time, and you're either going to be asked to find the total time or the half-life time. So from now on for half-life, I'm supposed to say life, sorry. Anytime you see half-life, you can just abbreviate that HL. Okay, so your chart's going to look like this. On the left, we're going to do number of half-lives. In the right, that will be amount. So in the beginning, no time has passed yet, so you're going to put 0 half-lives. So then you need to divide your times, given 2 types of time, so that you can find the number of half-lives. And you'll go ahead and number on that chart from 0 to whatever number that you found. So once you have the number of half-lives, number from 0 to that number. If you're given the starting amount, you're going to place it at 0 half-lives. If given the ending amount, sorry, not sure what happened there. You're going to place that at the number of half-lives that you came up with. So if you came up with 4 half-lives and they said you end with 2 grams, at 4 you'd put 2 grams. And then since it's half-life, you're going to just divide by 2, since it's half as much. Okay, so here's the starting problem. Now when they give you the name of the isotope on here, this is just extra information. Don't do anything with that number. But what we're looking for are the times and the amounts on here. So that's what we want to be looking for in this is what do you know? So here again I know days, and I know grams. So the first thing I need to figure out is how many half-lives this is. So I know I have 48.2 days. I'm going to divide that by the half-life time, which is 24.1. So this will be 2 half-lives. So that means in my chart, I'm going to number 0 through 2. Originally on here I have 100 grams, so I'm going to put 100 grams here, and it says how much will be left. So if I see words like is left, remains, that means they're going to go on the bottom. I'm going to start with my starting amount. I'm going to divide by 2, so 100 divided by 2 is 50, and then 50 divided by 2 is 25. So again, don't just think you're done at 2 half-lives. You're going to have to keep going until you get to the number of half-lives they give you. And then for your final answer, you can just circle it on the chart as long as you add the label. Usually it's grams, but sometimes it'll be milligrams or kilograms or something like that. Okay, so then we also have ones where we know the ending amount. You'll put it at the bottom then, and since we're working backwards, instead of dividing by 2, we're going to multiply by 2, we're going to double the amount. Now the one thing you don't want to forget to do is go all the way back to 0 half-lives. You're not done at 1, you're done at 0, the beginning time. Okay, so let's try one like this. So we have 96.4 days. So first thing we're going to look for are 2 amounts of times and then our grams. So 96.4 divided by 24.1 is 4 half-lives. If you're doing these right, you should get a whole number very close, like it might be like 2.99 or 4.01, but it really should be coming out whole numbers. So that means this time I need to number all the way to 4. And then this time on here it says there's 54 grams left, so that's going to go at the bottom. So now I need to work backwards on here. I need to figure out what number divided by 2 will give me 54, so I'm going to double it. So this would be 108, doubled again, 216, doubled again, 432. Now here's where you have to be careful. I'm not done yet. I need to go all the way back to 0. So my answer here would be 864 grams. So again, figure out the number of half-lives, put the ending amount at that number, and then double, working all the way back to 0. Okay, so the other type of problem is when you are given 2 amounts. You're going to start at the top with the bigger amount, because that's the one that had more radioactive originally. And then you keep dividing by 2 until you get to the smaller amount. If it just asks how many half-lives this takes, you'll be done at this point. And so say, you divided it 3 times and it's 3 half-lives, that would be your answer. But usually it either asks you for total time or how long the half-life is. So if they want the total time, you are going to take the number of the half-lives times the half-life time. So for example, 3 half-lives times 2 minutes and a half-life would be 6 minutes total. If they want the half-life time, you're going to take the total time, which they'd have to give you, and divide it by the number of half-lives. So for example, if they told me 5 half-lives took 15 minutes, I divide by 5 and figure out that the half-life time would be 3 minutes. Okay, so let's just look at another problem here. We're looking for the half-life of this substance. This means that they've told us how long this takes to do, and we're going to find the half-life time. So we look for our amounts. We have 100, and it ends at 12.5. So start at the biggest number at time 0. After 1 half-life, we have 50. That's not our number. We need 12.5. So do it again. Still not there. And then finally, we figure out that this is half-lives, 3 half-lives. So 3 half-lives equals 8,000 years here, but I just want the time for 1 half-life, so now I'm going to take 8,000 and I'm going to divide it by 3. And my time here, I'm just going to round to the nearest year, 2,667 years. Okay, so let's try one more on this. So we're looking for a half-life time. So we're starting at 0 with 0.800. 1 would be 0.400, and 2 would be 0.200. So 2 half-lives is equal to 10.5 years. So divide by 2. And a half-life is 5.25 years. Now let's say instead that they would have told us that the half-life time is 5.25 years, how long this would take. Then I would take 5.25 years times 2 half-lives, and then 10.5 years would be my total time. So if you're asked to do that instead, then you're going to multiply. Okay, so we'll practice this more next time.